welcome to Wireless Future. I'm Eric Larsson, and I'm here with my colleague, as always, Emil Björnsson. Hello, Emil.
Hello, I'm great. How are you?
I'm pretty good, thank you. So it's been a while indeed. How does it feel to be back recording?
Yeah, it's good. I'm in a new studio here with new lighting and everything, and a new green screen. So I hope it will be good as usual in terms of sound quality and everything.
Wow, that's amazing. I'm still in the old studio.
Right, yeah.
Yeah, always enjoying.
We usually use your background, and then I'm just virtually there as a avatar.
Yeah, putting this all together like so that it actually looks like we sit here, but we don't. I sit in Linköping and you sit in Stockholm, Emil.
Right.
And I always enjoy this. I always find this podcast recording with you is a great way to, well, read up on some new things and learn new things.
Yes.
So what do we have today to talk about?
So I found a new white paper about 6G and also looking back at 5G that SK Telecom have been producing.
SK Telecom. So SK here stands for?
South Korea.
South Korea?
Yes.
So this white paper, I mean, there are plenty of them, I think, out there on 6G, right? But this particular one, so it's a 6G white paper that also talks about lessons learned from 5G, and it talks about requirements for 6G and evolution and spectrum. So where did we get started? Maybe we get started with SK. So what is the SK Telecom?
Yes, so SK Telecom is South Korea's, I think, largest telecom operator, and there is a reason why I picked this white paper, not one of all the other ones that exists, because on the one hand, I think the operators are the ones who really know what they want to deploy in the future, while the vendors that are building technology might have other ideas about what could be cool to create. But then they've also been pushing a lot. They were very early with 3G. I think they had the first high-speed versions of 3G, for example. They were first with 5G, with millimeter wave, and they have been very active also in the 5G area with putting out their visions.
So South Korea has been a leader as a country in the development and rollout of this technology, and now we are like looking at the insights from a white paper by their main operator.
Yes.
So you said they were early with some 4G features and with 5G. Does this mean massive MIMO? Does it mean millimeter wave? Or what aspects of 5G are they mostly known for?
Right. So when people were sort of making plans for 5G, there were a lot of talk about we need to deliver 1,000 times more traffic. And then SK Telecom was one of those who was putting out the voice on how they thought we could achieve 1,000. And they were pushing a lot for small cells. So that's why they were also already in 2018 getting a millimeter wave frequency for 28 gigahertz. And they started deploying 5G millimeter wave, which only a few countries have done so far.
Why is that? Why is it that not more countries have deployed millimeter wave? I mean, I would suppose millimeter wave is mostly useful when you have very high population density in big cities. And of course, South Korea as a country is fairly densely populated. I think it's comparable to Netherlands in Europe, or even more dense. And it's a big country. Obviously, it has 50-something, I think, million almost population. But is there is that a correct understanding that the main driver for millimeter wave is when you really have a dense population and dense cities?
Yeah, that is my impression as well, because the range is rather short for these waves.
Yeah.
Not in line of sight, but as soon as you have buildings and everything around, then you get rather short range. You need to have a lot of people who can share the high capacity that you can deliver over millimeter wave. Otherwise, it might not be worth it.
Right. So it's mainly for very densely crowded places and cities. But is there a reason for why not more countries have rolled out millimeter wave?
So since you need to deploy a lot of more base stations than you would need at lower frequencies because of the shorter range, at least if you want to sort of cover large areas, then I think a lot of operators were sort of waiting and looked what happens in South Korea, and they were also seeing that maybe we can start with deploying massive MIMO in lower frequencies and then deploy millimeter wave.
Right. So basically you're saying that for millimeter wave to work, you need very densely deployed base stations.
Yes.
And South Korea were like pioneers in that deployment, and others have waited to see a little bit how well that worked out. So how did this work out then with the millimeter wave deployments over there?
Not so well, actually. So,
not so well.
So when they got the license, they were promising to deploy, let's see, 15,000 sites. And last year in May, they had only deployed slightly above 10%, so 1,650 sites.
Only 10% of what they promised. Yeah, it's always hard to relate like absolute numbers like this. I think the only way to really make sense of numbers of this sort is to divide by the population of the country to get some sort of base station per capita metric. But 10% sounds like as very little, in fact. Yeah. Why did this happen, or rather not happen? Do you have like a good, or does the white paper talk about that?
No, they actually don't talk about this in the white paper. I picked this up from the news instead. And what happened then was that I suppose they had a business plan for rolling out. I mean, you wouldn't buy expensive spectrum unless you were planning to deploy in this way. But then they probably figured out that, we don't get the coverage that we need. Users don't have good enough hardware components, and the base stations are not good enough. They are talking about the immaturity of hardware and services that needs this kind of technology. So what actually happened in May this year was that they had to give back the license, because they hadn't delivered at all on what they promised. And the same thing happened for the two other telecom operators in South Korea that also had millimeter wave. So they actually don't have any millimeter wave network anymore.
Oh, they don't have any network anymore. Wow. So that must be like a nightmare scenario for an operator to have to give back a spectrum license because of, failure in some sense with, or some way with the deployment. So what about in other countries with millimeter wave? I'm not sure. I mean, does the white paper talk about, or do you know, Emil, what about in other parts of the world? You mentioned that there were like only a few countries who actually deployed successfully.
So there's still millimeter wave in Japan, which I guess have a little bit similar density of people. And then in the US, I know Verizon have been pushing a lot for millimeter wave. But those are the only market that I know about.
Wow. Okay. So Japan and US. Of course, US isn't densely populated as a country really, but there are some urban metropolitan areas that are fairly dense still. But not in Europe. So no millimeter wave in Europe.
No. And I think in Sweden, we don't even have had any auctions on millimeter wave spectrum because there is no demand yet.
Right. Interesting. Wow. Okay, so maybe we should return to the main theme of the white paper, and it starts with a discussion of some lessons that were learned from the 5G deployment. So what were these lessons?
Right, so they're describing three main lessons, which are also a little bit interconnected. The first one is that there were a variety of visionary use cases or services that it was described a lot, that 5G will be about this, but there were no real killer service, as we say, not something that is dangerous, but something that would really makes people buying this equipment. So we're talking about 3D video, ultra high definition video streaming, AR, VR kind of augmented reality things, autonomous driving, remote surgery, and none of those things have happened yet, right?
Why not? Why do you think, or does the white paper give a reason for are we still not mature as a society to adopt all these new augmented reality and remote services? Or
So I think there is a mix of things. So they are mentioning things like the form factor, that if you want to build something like this isn't good enough yet. The maturity of the service or even the demand for it is rather low so far, and there might be regulations that are preventing some of these things.
Yeah, so the question is, of course, whether this will ever come, right? With like augmented reality, are we all in the future some point going to like walk around with a big helmet watching some projected computer generated image or overlay or not? It's difficult to predict cultural shifts, obviously.
Right.
But I can see that point, and also that even these gadgets seem extremely impressive, but they're still quite bulky, and we just aren't there yet.
Yeah, and I think there is a point there with that when you promise that a technology like 5G, which is something that will live for 10 years or so, will deliver certain new nice services, there isn't much reason for those services to be available from day one, because it's not like someone will develop devices that can only be used with a network that haven't been rolled out yet. But I think for some of those things are happening now. So you mentioned augmented reality. There is the Apple Vision Pro that they have been showing off, and I guess next year people can buy them.
Yeah.
I think they are meant for sitting still in your office and experience having a very large screen in front of you, in front of your eyes. So it might not be meant for mobility, which is also what cellular connectivity is meant for.
Right, and once folks want to use these devices outside of the office and really move around, then we will need wireless connectivity that can support not only these rates but also support that mobility, obviously. Yeah.
So the second thing they were mentioning was the gap between sort of the 5G visions that they were describing and what people were expecting, because to some extent this is of course connected with the services, but if you say, we will be able to deliver 20 gigabit per second, or it will have this and that latency, and then people don't get that from day one, they will of course be disappointed, because we think that this 10-year generational shift will immediately bring us great differences.
So do you think the technology was like oversold, that when the 5G concepts came about, that vendors and operators just promised too much and that never materialized that promise?
So I think there is a educational issue with these type of things, because you might develop the technology with a certain vision in mind that once we have 5G we will be able to support this and that services eventually. But when you're talking a lot in media about how the technology will be the enabler of autonomous vehicles or this and that, remote surgery, then people expect that to happen rather swiftly, but it's not, and we're not even there yet.
It's not, Yeah, this is a good point, yeah. So any other lessons that were learned from 5G?
Right. So the third thing they mentioned is something that is related to millimeter wave. They don't say it explicitly, but they phrase it like need to consider various frequency bands and technology maturity. And I think that
technology
really means,
maturity.
Yeah. And I think that is the issue with that. Both the base station hardware for millimeter wave was probably not. I mean, it's a very advanced new technology that haven't been deployed very much, so probably that one wasn't so efficient. The coverage wasn't good enough, and then the user devices, I've heard at least that it's quickly getting so hot that you can't use 5G for extended periods of times with at least the first devices.
Even the devices get hot, which of course also means a lot of heat dissipates, and that heat has to be generated from energy ultimately drawn from the battery, right? So there's probably a battery issue as well connected to. Interesting. And then obviously, as I think we talked many times before, Emil, that millimeter wave has somehow the physics is against it because of the coherence time at high bands, which makes more difficult to support mobility, and because of blocking and also the shrinking of the antenna effective area when you go up in frequency. So did all this 5G all happen too fast?
I think there is certainly that kind of issue because there were first a time plan, and then after a while they were speeding up that time plan as well because, for example, I think in the US they wanted to deploy fixed mobile broadband using 5G technology and wanted to sort of roll out things quickly at different markets. So then they created this non-standalone version of 5G where the idea was that, okay, we feel that we know a bit about how to have the radio interface, so how to build the base stations, but everything that is behind that, the core network, or should you connect your device to the 4G or the 5G cell first and connecting those things together, they enable you to deploy non-standalone 5G networks, and there are 7 different ways of building that.
So non-standalone here means like, do you just replace the physical or like the antenna units and keep like switches and backbone network and all of that?
Yes, that's one version of it, and it could be that you keep whatever you have and you add an additional base station. Your device connects to the 4G network, and then the 4G network knows that there is a 5G network, and whenever you have data, you connect to the 5G bands as well. So there's a lot of different mixes of this.
I can see. So then I guess one question is like now, with these issues that we had with the 5G rollout, how could those issues be avoided or fixed in 6G?
Right, and here SK Telecom is putting a lot of emphasis on virtualization and open interfaces. I think
so. Virtualization here. I feel like we have to break this down. So virtualization means
right. So. Conventionally, every piece of hardware is sort of the hardware is built for doing certain things, such as the baseband processing, for example, and it is really fine-tuned the hardware to do just one thing, and if you want to update things, you have to replace the whole box. And virtualization is the idea that you are using more general purpose computers and you software define a lot of the different processing so that you can update it more easily.
That sounds to me like that goes against the trend of building like more specific hardware which is optimized for specific functionalities and could also be made a lot more energy efficient. I mean, it's a little bit, it sounds at the surface like running everything on a general purpose computer. You certainly could do that, and everything is implemented in software, but you lose the opportunity to actually optimize the hardware. And this is now in a world where energy efficiency is becoming more and more of an issue. Is there such a trade-off?
Yes, there is such a trade-off. It might not necessarily be that easy that it only goes in that direction. I think this is connected to what is called Open RAN as well, that traditionally if you are buying these different boxes that you need for the baseband processing and base stations and so on from one vendor, then what interfaces you have between the boxes, that wasn't standardized. So the operator sort of can optimize it certainly in their best way and what they thought was the best way of doing it, but you also sort of get locked in. And then the idea with Open RAN is that the interface between all the different boxes that you need in your network would be standardized. You know what kind of messages you can send in between them, but then you should be able to buy the different boxes from different vendors. Hopefully they can be optimized more swiftly. There will be more of a market pressure to do things better, but I think the risk is that a lot of things also becomes less efficient.
Right, and possibly less. I mean, somehow my understanding earlier had been that vendor or operators and customers like to build everything from one and the same supplier or vendor, because then if something goes wrong, they know whom to call to have it fixed. But if you buy like one component from this vendor, another component from that vendor, and then these components don't properly talk to each other, it isn't so obvious whom to call or even whose fault it is. So is it true that this Open RAN, so Open RAN and open interfaces are basically the same thing, are they? Because you mentioned at the beginning, I think, open interfaces. So is there some is this a controversial thing at all with Open RAN? I'm asking because as Invited wants to give a speech at a conference, but it wasn't a condition that I don't talk about Open RAN. And I reflected over it and thought that there's something here that's controversial, possibly something even that I don't understand well. But do you know this, Emil? Is this a big point of controversy?
So there are certainly some sort of competition aspects to this as well. So we have only a few big vendors that can deliver an entire network today. So if you only have to choose one vendor to buy everything from, you have to pick one of those. And then I think operators would very much like to have more competition. And since it's hard for one company to be able to deliver all the different boxes that you need to build a network, Open RAN is enabling more competition so you can buy from different places.
Right, because new vendors could pop up and just sell specific or particular components, then assuming they follow the spec, then would just right out of the box fit in and work together with the rest of the equipment, so that they should facilitate reduction of costs and improved competition.
Yeah, then I can imagine that many of the operators actually don't want to buy their equipment from unproved small companies and mix and match whatever, but they want to have this as a leverage against the big vendors, because if you build an entire 5G network or 6G network for that matter from one vendor and then something breaks and you need to buy a few more boxes, they say, actually we have increased the price on these boxes by 50% since last time, it's supply chain issues. So then you want to have this possibility, okay, I can actually buy from someone else.
Right, to buy from different vendors, yeah. So that should be obviously an advantage as an operator.
Right, but and then virtualization on its own have benefits in the sense that instead of having one baseband processor per base station, you can put this once on a server which is located a few kilometers from the base station, and it can be shared between many different base stations, because usually not every base station have full load at the same time. So if they can pool their needs at one place, you can also sort of reduce the amount of computational power that you need.
So you mean even shipping the actual baseband data off the site for processing elsewhere? Interesting. Okay, so basically you're saying that the approach to avoid these issues that were there with the 5G rollout would be, in the view of the SK white paper, virtualization on one hand and open interfaces, Open RAN on the other hand.
Yes.
Which seems possible, but not totally, I think, obvious, considering all aspects of the issue.
And I think what they're after is some kind of forward compatibility, so that if you are finding better ways of doing things in the future, you are not hit by the fact that you were early with deploying something, because you can always update the software without having to tear down your entire network and deploy something that is more efficient.
So forward compatibility, really meaning that you could install essentially new firmware once new features become available or new needs, but keep like the hardware platform.
Because also this non-standalone thing, it was only able to deliver enhanced mobile broadband and not all of these other services that was promised and that people were expecting. So I think operators gave themselves the possibility to deploy 5G early, but also to make it more expensive to actually achieve that 5G experience that people were expecting, because you have to then buy new hardware later on.
All right. So where do we go from here, Emil? Should we shift gears a little bit and talk about something else? How about AI? Because the white paper, I think, also mentions AI as an enabler. And of course, everybody's talking about AI, and it can mean a lot of different things depending on the on the context. But now, in the context of the 6G white paper, how is AI seen to be an enabler for new functionality that 6G will offer?
Right. So many people are talking about, AI, we want the 6G networks to be AI native. And I've always...
AI native.
Yeah, and I've tried to understand sometimes, what does that really mean?
Yeah, I have to admit, I don't think I understand what it really means. Is there like a consensus on or a definition of the term?
Yes, so I think it goes like this. So, of course, today there are a lot of data analytics being done in the base stations in order to figure out how you should optimize different interfaces, particularly perhaps resource allocation things, usability, when now there's a lot of users in the cell, when can you turn things off and such things. But you need to sort of be clever with implementation. And the idea with 6G native is that you would already standardize from the beginning how you can collect data and share them between your different boxes in the networks and use that for improving different features. So you will standardize that kind of data collection and analytics.
So there would be like some general AI algorithm that just sucks in all data from mobility and beams and cells and so forth, then makes that like trains on a lot of historical data and makes decision. Is that the vision? Or I mean, how much of classical algorithms would actually be replaced by AI here?
I would imagine that you don't want to change things that really works, but there are a lot of different aspects, particularly when it comes to user behavior, that is hard to predict in advance and that you want to tune differently in different cells, and therefore if you start from man-made algorithms and you fine-tune with machine learning, I think that is what you're after.
Yeah, user behavior modeling sounds like a golden use case for AI and learning algorithms in my ears. Then obviously there will be lots of other functionality where it's difficult to see that AI has a lot to offer, but there's certainly problems for which we just don't have any reasonable physical models or even good classical algorithms, and there AI could make rather big difference.
So they are mentioning 6 specific things that they think are interested. And of course, some of those things are already discussed now in 5G. One of them is that when there is not much traffic in the cell, you would like to turn off certain pieces of hardware to save energy and then turn them on again as soon as there is usage.
That Emil doesn't sound very 6G-ish. I mean, turning off something when it isn't used is like teaching the kids to turn off the lamp or the light when they leave the room, right? They should have been there from like, if not the first generation, at least the like second or third of cellular technology, is what it sounds like to me.
Right, and I think the thing is that you don't want the user to sort of say, oh, now I will be turning off for a while, but it's more like, when does the kids leave for school? Can we learn that? And then we can turn it off immediately, and then we can turn it on again when we expect them to come home, and maybe they are following a schedule, so there is some kind of predictability there.
Yeah, and also I suppose turning off is one thing. It's actually, I mean, turning off is quite easy, right? Just shut the power, but turning on might be more difficult than actually turning on quickly enough that users don't experience unduly delays or other trouble. Another thing you mentioned was like mobility in the cells, I think, but I thought 6G would be a lot about cell-free access and cell-free MIMO, that I think both of us have in the past done some academic work on the topic. Is there like any consensus, or does the white paper have any opinion about cellular or cell-based communications versus this notion of cell-free?
So they don't talk specifically about the cell-free aspect or even collaboration between the base stations. What they are mentioning related to this is mobility management on just resource allocation between different frequency bands. Because I think when we are considering cell-free in our research, we consider one frequency band and how you handle mobility and things there. But if you now have 4 or 5 different frequency bands, you want to put users in the best location and handle the load between those bands. And I think that is a difficult problem that AI might be able to deal with.
It absolutely is. And that's another thing or problem where it sounds like AI could be a very useful and effective enabler. So shifting traffic around multiple bands, and I suppose these bands could be quite far apart or not. I mean, are we now discussing like devices that could connect to maybe sub-10 networks and to millimeter wave and others simultaneously? And then that becomes like an interesting question, how to optimize the assignment of bands. So I think I interrupted you too much. You mentioned there were like 6 directions where AI would be native in these networks.
And I think we have mentioned 3 of them now, with energy savings, with switching off things, load balancing, mobility management. They're also mentioning cell shaping by beamforming. This is sort of...
So that's another thing that kind of sounds slightly dissonant in my ears now, given like the trend in 6G research towards cell-free, that shaping cells. I mean, if there aren't any cells, then why would we shape them? What is there left to shape? But fair enough. Let's see. So
then they mentioned link adaptation, which sounds like something that would be easy to deal with, but apparently it's not as easy in reality, because you're transmitting relatively short blocks of data. Maybe the codes are spanning some 5 to 10,000 symbols or something like that, and then the interference that you are experiencing there might be hard to predict, and that will have a lot of impact on your link adaptation. And then finally, there are these type of things, compression of channel state information if you pass it around, beam management and positioning accuracy, things that are, I guess, particularly relevant if you are using analog implementation in the millimeter wave.
Right. So in summary, I mean, a lot of implementation matters where we currently don't have good enough algorithms, and where AI and machine learning could come to rescue, relying on the collection of large amounts of training data, I suppose, and really adapting. I mean, once you cold start the system, it might take a while for the network to really burn in and learn how to operate efficiently, but over time it will.
Yeah, and you want to be able to enable these AI algorithms by having this means of collecting, passing around data, analyze them, make decisions, and then store the data.
All right. Great. So I think the next thing that I wanted to talk with you about is from the white paper's perspective. We touched upon this already, but maybe there's more to say on use cases. And then we have use cases both for like consumers and for industry and possibly other like entities or stakeholders. We started with consumer use cases for 6G. What are they that we can't support with, let's say, 5G that's available today?
Yeah, and I think here we are coming back to this issue that we talked about earlier, that there is this natural delay between when the connectivity gets deployed and when you can reasonably release a new customer product that will require that kind of connectivity. So it really becomes a natural delay there, so there won't be any devices when 6G are released that can only be used on 6G. That is my guess. But the general thing that they are looking for at SK Telecom is, they say, lifestyle innovating services breaking the constraints of time and space.
Lifestyle innovating services breaking the constraints of, you said,
time and space.
Time and space. Wow. Well,
so I guess one of those things are then extended or augmented reality kind of things, like the Apple Vision Pro.
Yeah, I mean, it sounds like a grand statement, right? But it probably comes down to augmented and extended and mixed reality. In the end.
And I think if it gets popular enough so that you want to do this with mobility, well, then you will certainly need a cellular network. I think if you're sitting in your room, I believe that the Apple Vision Pro will be using Wi-Fi to start with as well. And maybe that's enough if you're sitting at one location.
Right. At one location. But once you get moving, like dancing out on the street, then that will introduce a whole lot of new challenges for the connectivity.
Yeah, and I think if people will be walking around and mix their reality that they are seeing with augmented things, you don't want to go around the corner and all of a sudden everything disappears. You want this really consistency in performance everywhere.
So how about other use cases, like for industry, for example, and for autonomous vehicles and driving? Are there any new visions there as compared to what was discussed for 5G?
So they are mapping this lifestyle innovation also with autonomous driving. So there is the level 4 type of autonomous driving where you can leave everything to the car and you can just sit back in the car and do other things. And that will sort of give you more time and space to do other things, essentially. But of course, all of these use cases that I'm mentioning are things that were already mentioned in the 5G era, because if you just put together a number of communication engineers to predict the future, they will come up with all of these type of things that are obvious, and then it just might take time before we can deliver it.
Yeah, I mean, honestly, there is nothing really here that I had not heard already in 5G or vision, let's say, discussions much longer ago. But it's one thing to talk about a vision, a different thing to actually formulate even a requirement spec for a technology, obviously. So anything else that wasn't there for 5G that's worth highlighting, or that the white paper talks about?
So I think in the industry case there, nothing really have taken off when it comes to 5G yet, and maybe we will have to wait for 6G before things really happening. So if we had these 3 use cases, one was enhanced mobile broadband, and then there were the massive machine type communication, so a lot of small sensors, and the ultra reliable low latency things, both of them targeting a lot of industry kind of applications. The issue there is that on the one hand we see that our society is getting digitalized a lot, so it's natural that we will need this kind of services in the future, but it also takes a lot of time because there's huge investments. So just look at in the factory where you will be building a new car or something like that, it's billions or more that you need to invest in that, and then connectivity is a small part of it. And if you're used to not using wireless connectivity, you really need to make a big effort to push that into it.
And of course, the added value has to be there, right? And I mean, wireless is great, obviously, but it also fights a different physics than a wired connection does, with susceptibility to interference and blocking other links and all sorts of things.
Yeah, and I talked with ABB, the Swedish company, or semi-Swedish at least, that are building a lot of robots for factories, for example. And they are really looking for what they call functional safety, that it must work all the time. It's cost a lot of money for every minute that the factory can't operate, and they don't see that 5G can deliver that yet. So they are very keen on actually improving technology in order to have the connectivity that is needed to really transfer everything into wireless there.
Yeah.
But I guess in general, a lot of the talk so far is sort of low energy, bigger MIMO, refining protocols, more robust and resilient core, and yeah, it's the same kind of things.
Same kind of things as we had like for 5G, you're saying, or I mean,
yes, exactly.
This is much of this sounds like music to my ears with bigger MIMO and lower energy and so forth, but. There's got to be some things, I guess, that are more novel than others, at least.
So one more thing that is happening is sort of 3D networks, so aerial networks. So both in terms of connecting flying objects like airplanes or drones to. So I mean, today if you are playing with your own drone, you need to be in line of sight and you need to control them. But if you want like to have some delivery of drones in the city, you would like to connect them, and you can also view it from the other viewpoint that you would like to use satellites or some kind of balloons that would provide you with connectivity from above.
So again, let's break this down. So aerial networks, it sounds to me like it means two different things. On one hand, to use like base stations that would be deployed on satellites or on flying objects or somewhere well up in the sky. And it also sounded like it is about creating a network between or among flying objects themselves.
Yes.
Is that yes?
So they are certainly two different aspects, and I think that when it comes to supporting flying things, usually you put your base station, you tilt them down towards the Earth where the users are supposed to be, and you need to think about other ways of deploying them potentially in order to provide good coverage over the sky.
So actually designing base stations that radiate power upwards into the sky and not just down into the cell.
Yes.
Yeah, but I mean, it does sound to me like the technological challenges are quite different in between of number one, making base stations that fly around or are deployed on satellites, and number two, ensuring coverage of a 3D space to enable connectivity to airplanes and maybe drones and similar. So this could be some, I mean, could be partly my ignorance, obviously, but it sounds like something that I did not hear so much about when 5G was discussed, and perhaps it is something uniquely novel and that might come in 6G. Is that a correct understanding or coherent, consistent with your understanding, Emil?
Yes, I think there were a willingness from the satellite business to be involved in 5G, but it didn't really happen. I think what they are looking for now is that you make sure that the 6G standard can also be utilized for connectivity with satellites, so that you're using the same kind of protocols, air interfaces, and so on. Because as we are moving towards millimeter wave or upwards above 6-7 gigahertz, we are approaching the frequencies that are usually used by satellites. So then it's natural that if you would be using the same kind of interfaces, the mobile phone could directly connect to these networks. The only problem is, of course, the path loss, because they are far away, though in line of sight.
Yeah. Wow. All right. What else is there to say about 6G, or what does the white paper have to say? So one question obviously is spectrum. Huh? What bands? So will there be like new bands that would be used and exploited for 6G? Is that where's the vision there?
Yeah, typically you want to have new spectrum so that you can deploy a new 6G network in that spectrum and not having to immediately tear down the old networks that you're having. And this is one of the complicated things, because there's of course limited spectrum and you are competing with other technologies as well. So the white paper is talking about 4 different kinds of spectrum here. The mid-band, which is sort of from maybe 2 gigahertz up to just before millimeter wave, so up to say 24 gigahertz. So that's a lot of spectrum. They are splitting it up into two halves. The lower mid-band, which is up to 7, which is what we are essentially using now in 5G as well. And then the upper part, which is in between that and millimeter wave.
Okay, so let's recap this. So lower mid-band is from like 0 up to 7.
Yeah.
Upper mid-band is from like 7 up to... Where does millimeter wave actually start? Like 30 or something? No? 28 maybe?
Yeah, so it should be 30 if you want to sort of say, this is 10 millimeters. But then it usually starts at 24 because they happen to be spectrum at a few markets at that frequency.
Yeah, okay, got it. So 24. I think I erroneously said 28, but 24 really. So from 7 to 24 is the upper mid-band. And then from 24 and upwards is...
Yeah, up towards 92 or 100 gigahertz, we call it millimeter wave.
And then at the 100, we hit the sub-terahertz.
Exactly.
Yes, range.
So these are the different ranges then. And then if you want to build 6G in a band, you want this same band to be used not necessarily over the entire world, but at least over big regions of the world. So that is when the ITU, the International Telecom Union, comes into place because they are helping out with harmonizing this around the world.
So the ITU.
Yes, and the thing that we call cellular, they call this IMT, International Mobile Telecommunications.
IMT, International Mobile Telecommunications. So I think we are now walking over like land where I feel I have rather little knowledge, and maybe we should do an episode in itself on how regulation and spectrum allocation works. But there is the IMU that ultimately makes decisions in some sort of consensus among different countries in the world. Is it like that?
And every 4 years they have a big congress, World Radio Communication Congresses, when they are discussing, should we make any changes? Should we allocate certain spectrum band to this IMT, meaning to 5G, 6G or whatever? And there is one such conference now in, I think, December, but at least this year. And then there will be another one in 2027. And there isn't that much proposals for 2023 regarding what to use. There are some proposals to start allocating something in the upper mid-band towards 6G. But otherwise, it's in 4 years' time where the really tough decisions will have to be made to allocate something new.
Yeah, I mean, it sounds a bit like a tough call, right? Given that millimeter wave deployment, as we discussed at the beginning, didn't really succeed so well, than to come and ask for even more spectrum, especially around those frequencies. It's one thing to ask maybe for like more low band or sub 10 or 7, whatever, but to ask for like, well, 30 gigahertz millimeter wave didn't work out so well, so now we want more at 28. That sounds like a tough call or a tough request to come with, so it'll be quite interesting to see how all this plays out.
Yes, I think this issue will certainly be there because it's not like there is a lot of spectrum lying around that no one is using. So if we are now zooming in at this upper mid-band, because the millimeter wave had too difficult propagation conditions, we want to find something between 7 and millimeter wave, then satellite are using a lot of those things already, and then it will be a lot of tough discussions there. Should we really give more?
Must be nightmarishly hard to get countries from all over the world to agree on which bands, because there might be vested interests and domestic interests that aren't compatible with among countries. So then, of course, I mean, moving even higher up, there's a sub 10 or sub terahertz band starting at about 100 gigahertz, right? And I mean, up there, spectrum is basically just for free. There's just so much of it that we don't need to care really so much, maybe, about spectral efficiency and out-of-band emissions and all of like the classical constraints that we had in the IMT bands.
Right.
Is there a lot of talking about where to go there with and how to use the terahertz frequencies?
So I think in order to use the sub-terahertz frequencies, since there are already some systems using some of those frequencies, there needs to be a sort of decision at one of these World Radio Congresses in order to decide on should we look into coexistence between these existing use cases and what you're proposing for cellular, and to set what kind of out-of-band emissions and other things that you are allowed to have or transmit powers. And there is no proposal about that this year. So I think that we need to see there in the future, will there be new proposals around that before sub-terahertz actually have a chance of becoming reality?
Yeah, before it actually has a chance, yes, to become relevant. Of course, I mean, again, at sub-terahertz, bandwidth is unlimited, right? But the physics is more difficult because of small antenna areas and even high mobility, even worse than at the millimeter band. So that'll be highly interesting, I think, to see how this eventually plays out.
Yeah. So what Sweden and a few other countries have proposed for this year is to look into 3, 7 and 10 gigahertz bands. There are some specific frequencies there that they want us to look into. Can we allocate this for 6G? And if any of those things are approved, well, then that will be analyzed, I guess, during the next 4 years until the next Congress, so they can decide on then if something will be allocated for 6G.
Right. So it'll be quite exciting to follow and see what is eventually decided at this Congress. Wow. All right. So I think our discussion here today has mostly been around the white paper, but also a little bit intermingled with your and maybe mine personal understanding of matters. So I guess a natural question here is how much of consensus is there out there on because now we talked about one specific white paper, one specific company, namely this operator, right, SK Telecom. How much of consensus is there? Because there's a bunch of other white papers that have been written about 6G. So how much consensus is there about all these matters with 6G, with the possible points of controversy and contention like virtualization and Open RAN that we touched upon, and about the importance of different spectral bands and about what applications they will drive the development. And there are a few things that we didn't touch at all, I think, here. One is reflecting intelligent surfaces. How important will they be in the 6G deployments? And we didn't talk, I think, at all about energy neutral and backscattering communications. And we didn't talk about sensing, I think, integrated sensing and communications, which is another thing that a lot of folks in academia work on. And we didn't talk about semantic communications, which is another direction that some folks in academia are investigating. So, but overall, do you have a good feeling for how much does this white paper, does it differ? I mean, it opines on a number of issues, but how much does it differ from what the opinion of the, if there is anything like a consensus, but from what others in the field think?
So the other white papers I looked at are providing somewhat similar kind of opinions about things, but yeah, you mentioned some of these other technologies or aspects, and I think some of those are discussed at other places and will become important. But the way that this really works is that this ITU organization, they have a radio section that is putting out requirements for something being called 6G, and then you need to let companies, in this case 3GPP, where it would be the organization where companies are agreeing upon how to build 6G in order to reach those requirements. And the requirements aren't there yet. So that is also up in the air. But there were a first meeting in June this year in the ITU where they were discussing what would be the requirements. And they haven't put any numbers or anything like that, but they will eventually put out a report called IMT 2030, which is sort of means what requirements do you need for technology to be called 6G. And there they have at least started to talk about use cases and what kind of metrics they will consider. So I can mention a little bit about that. So when it comes to metrics, it's of course better data rates, better spectrum efficiency, better or shorter latency, higher reliability. So the things that we already have, and there they will be tuning.
I would even say the things that we've been talking about for decades.
Yeah,
right?
yeah,
It's
exactly.
always been there, like in wireless connectivity.
But they do have a few new capabilities that they are specifically labeling like that, and that is about coverage, about sensing capabilities, about AI capabilities, so the thing we talked about there, sustainability, interoperability, which I guess is the Open RAN kind of thing, the openness there, and positioning. So there will be some particular requirements related to all of those things. Then when it comes to use cases, we have those three that I was mentioning: mobile broadband, massive machine type communication, and ultra reliable low latency. And those things will remain. They will rename them to something new: immersive communication, massive communication, hyper reliable low latency communication. That seems to be their names, but it's essentially the same kind of use cases. You just crank up the numbers a bit. But also there they have a few different new use cases that they are mentioned. So 3 of them. So you get 66. So it's integrated sensing and communication, which I personally also think is a nice topic. Ubiquitous connectivity, which I'm not entirely sure how they are defining, but maybe this is also sort of related to high coverage.
I think it's just another name for coverage is what it sounds to me like.
And then finally, integrated AI and communication, which I guess is also something related to both AI within the network, but possibly also to support some kind of AI going over the network.
But that's a whole different thing, right? I mean, it's one thing to use AI algorithms within the network to solve algorithmic problems, which I would not consider a goal in itself. That is just like an enabler, just like any other piece of signal processing or optimization algorithms that go in there. But using the network to support AI algorithms, that's something else.
Yeah.
Like collecting data from edge devices to that collaboratively trains a machine learning model, for example, in the cloud. And that is something that seems a little bit more novel to me, and that was not discussed so much, I think, for 5G. So there does seem to be a few new things here, which I guess is good news for us working in the business of, let's say, wireless comms and the related.
Exactly, and I think when it comes to enabling AI over the network, we had a previous episode where we talked about that as well with Carlo Fischione, who was visiting us.
In fact, we did, yes. Wow.
Yes, that's it.
That's it. Yeah, so thank you so much, Emil. It was a great discussion. I learned a lot of new things, and hope to continue discussing with you again new topics.
Yes.
In a next episode.
And of course, we are so happy that people are listening to the podcast, and that is the reason also that we are continuing doing that. In addition to just having a nice conversation, we also record it for you.
Absolutely. So don't forget to log into YouTube and hit the like and subscribe button.
Yes.